Afternoon, everyone. Maybe we'll, that's what happens when you start saying good afternoon, people turn up. So we are going to be working through calculating missing sides and angles using the sine rule. Okay, so here is an example of one of the questions. And a lot of the questions ask you to solve the triangle or solve a triangle. What they're asking you to do there is just find every missing side and angle. So in this particular story, you're told angle A is 30, angle C is 70, and that side little b is 5. And from just that information and no other information, we are able to find everything else. Now, depends on what they give you, how you're going to approach the problem. So I'm going to always start by making sure I name the sides. And now I'm going to put in, I guess I'll do it in green, everything I know. I know that angle is 30 degrees because they tell me. And I know this angle here is 70 degrees because they tell me. And very often when I've got a question like this, I have a little look and I say, is there anything else I can write down without doing too much work? Can you see anything else I can write down on this triangle without doing any extra work?
Angle B.
Correct. And since this is 30 and that's 70, isn't that 80 degrees? Are you comfortable about why that is what it is? I mean, I could write the working at the side, but isn't it 180, take away the 2 that you know? Right, 180, take 100, you got it. Now, once I've said to myself, that's it, there's nothing else I can do, I then move on to this phase where we do the sine of A over little a, the sine of B over little b, and then the sine of C over little c. And we check off everything that we know. So we know angle A, B, and C, and we know B. And then shouldn't we check off either what we know or what we'd like to find out? Can you see in this question, couldn't I use those two to find little a? And couldn't I use those two to find little c? Do you think it really matters which one I use to find which side first and which side second? No, doesn't matter. So which one do you want, A or C?
A.
A, for alphabetical purposes, that'll work. So since I'm using these two, it's going to be the sine of 30 degrees over little a is the sine of 80 degrees over 5. And we do the cross multiplication. A times sine of 80 is 5 times the sine of 30. A then is 5 times the sine of 30 degrees divided by the sine of 80 degrees. And then I'll go over here and type it in. So 5 times sine of 30 and divided by sine of 80. And the answer I get to, what are they asking for? Oh, to the nearest whole number. Well, that makes my life easy. Ooh, I want to check something here. Oh, different question. They want this 1-to-1 decimal place, so the other one that I was scanning was to the whole number. Right, 2.5 degrees, bit on the small side, but math says it is, so I'm not going to argue. So I can go up here and I can say, okay, I now know you. You are 2.5. Now, the only guy left is C. Couldn't I use B and C to find missing C? Couldn't I use A and C? Right? And does it matter? No, just be careful you're rounding off, you're fine. So which one do you want me to use with sine C? Just pick one, it doesn't matter.
B's fine still.
Yeah, why not? So it's going to be the sine of 80 degrees over 5 is the sine of 70 degrees over c. C times sine of 80 degrees is 5 times sine of 70 degrees. And then divide both sides by the sine of 80 degrees. And then time for the calculator. So 5 times the sine of 70 divided by the sine of 80 into 1 decimal place, I make that 4.8. And we're done. What does that look like in the homework? It looks like this. You get a little box with A, you get a little box with C, and you get a little box for angle B. Now, although they were written in that order, actually, didn't we find this one first? And then we found this one second. I don't know why I'm putting degrees on, that's just a number. And this last one was 4.8. Are you comfortable with that particular question? Right? It's got a kind of flow to it. Bear in mind that when you do these, solve the triangle, 3 things can happen. In this particular one, didn't we end up with situation 1? There is only one triangle. The minute these 3 angles are committed, isn't that kind of guaranteeing there's only one answer, right? And a different combination, you may get 2 triangles. Of course, couldn't you get no triangles? And sometimes that's allowed, right? That can happen. Can you imagine I did a calculation, not this one, but I could do a calculation where this was impossible, right? Where it was, you're trying to find an angle and it's the inverse sine of 4, right? That would be a situation where it would be impossible. This particular one came out fine. Let's pick one with 2 solutions in. So this one is a version of question 10. And we are told somewhere or other that A is going to be 30, little c is going to be 42, and angle A is going to be 33 degrees. And the way the question's set up, this is going to have 2 solutions. So being a kind of visual person, I like to have pictures. It helps me figure out what's going on. So there's my little B, there's my little A, there's my little C. You've told me that angle A is 33 degrees. You told me little a is 30 and little c is 42. So far, so good. Right, now when I look at that triangle, would you agree there's nothing else I can add easily, right? Not like the last one where, okay, 2 angles, you get the third one quick. So what I'm now going to do is do sine A over little a, sine B over little b, and sine C over little c. And I know angle A, and I know little a, and I know little c. These are 3 things that I know the value of. The only thing I can check is something I need to find out. Would you agree that in this case, it's angle C that I'm going to be finding, right? I can't do the other one in the middle. Too many things are missing. So we are going to be doing sine A over little a, sine C over little c. So it's going to be the sine of 33 degrees over 30 is the sine of angle C over 42. The cross multiply gets us this. Divide both sides by 30 gets me that. And to get angle C, we now use the inverse sine button. So it'll tell me what angle is equal to this expression. So it's 42 times the sine of 33 degrees all over 30. Right. So inverse sine of 42 times the sine of 33 divided by 30. And the answer I get is, to one decimal place, 49.7. Does that look good? Okay. So angle C is 49.7 degrees. Then if I go up here and I put in 49.7 degrees, we're good to go. But of course, couldn't there be maybe a second answer? We talked about this yesterday, but if you have an angle here that's 49.7 degrees, right? That means that distance, that angle is 49.7. Isn't there another one over here who can also give you the same result? That means there is a second possibility for angle C. It's always 180, take away the one that you've found. Now, if you do a quick subtraction, that's 130.3 degrees. If you look at this triangle that we have, this angle here is 33 degrees. Is there enough room for that one? Do you agree? You can make it. That makes this a two-triangle world. Right. Can we just pretend for a minute that that angle C was 80 degrees or something, right? Okay. Oh, let's make it small. It was 5 degrees. There wouldn't be enough room for the other one, right? In fact, anything over 147 would be too many. So there are going to be two answers. The other answer would look like this triangle in green. So we would be, that would be 30, that would be 42. There's my little C and my little B. Now, if I finish this triangle off, that's 33 because we were told it, right? That's 130.3. Doesn't that mean that we can now get the third triangle just by adding up and saying what's left? So angle B in this story then is 180. Take away the two guys that we know, 33 and 130.3, and I get 16.7. If I now return to the first triangle, I can also get him. If you add these and take away from 180, let's see what that gets you. 180, take away 33 and 49.7. And this angle ends up being 97.3. So if I put those two triangles kind of side by side here, to see that they're quite, you know, there's quite significant difference in these angles, right? Quite different. Now, if you do this triangle, you know everything pretty much that you want. Don't you now know all three angles? And you know C, and you know A. Can't you now get the last guy, which is B? And I'm not doing that one, but you know how the math would work, right? Couldn't I do B and C or A and B and I'd get it? Now, if I go to this triangle, can I also find the third missing side? And this time it will be different. I'll actually tell you what it is. In this guy here, it ends up being 15.8. And in the one that we've got here, it ends up being 54.6. So there are two triangles with the same starting angle, and these two sides are the same, yet you end up with two quite different looking triangles that have the same starting information. If you got a triangle that was impossible, what would essentially happen is, do you see when I got to this line here, when I tried to find angle C? This expression here would be bigger than 1. Right? Any number bigger than 1 doesn't work because the sign can only be 1, that's its largest. And the calculator would tell me by saying error, right? So if you get one that doesn't work, it's kind of easy to do because after the first calculation, you'll probably see an error, won't you? Oh, you can't, that triangle don't make sense, it can never happen. Any questions about, these are quite long, but it's really just doing the same thing over and over again, right? There are only 2 questions. Find a missing angle or find a missing side. Isn't that the only 2 real questions that you deal with? And so I'm choosing not to spend too much time doing all of that over and over again. So I think what we should focus now on are my favorite kind, which are puzzles. So here is a version of question 14. I'm going to try my best to draw the picture that they've got. And this is called B. This is called D. This is called A. A triangle kind of like that. That's pretty good for me. For some reason, they're calling this side U, and they're calling this side here V, and they're calling this side here W. Oh, and in red, this guy is 17. This guy is 17. So I'll rub out those letters. These 2 sides here and here are both 17. And the one over here, I'll rub it out as well. This side here is 28. And you're also told that this angle here is 30 degrees. So 17, 17, 28. And there's our shape. And we're being asked to find 2 things. Find angle BCD. And that's going to be question A. And question B is find the angle DCA. Okay. If you look at this picture, the angle BCD, I should say, isn't it that angle in there? I'm going to call that guy theta because I like theta. So this question is going to be find theta, right? And then DCA, wouldn't it be this little piece in here, the one I'm shading in dark, right? I won't call it anything right now. Are we good so far? Any, I'm looking here because I feel I need to find some things here. I don't like it when questions ask you in things in order. Remember the last question, we actually found the angle first before we found the 2 sides. And the reason I don't like them to do it in this order is that it makes you think you should find this one and then find that one. But that's actually not the case. I'm going to find that dark shaded one first. I hope. A quick check here. I think there's something missing actually. Let me check. A over A, that's good. C over C, yeah. B over B. Okay, I've got that one. A, B, C. Oh, I changed my mind. Tell me what I'm going to find next. Now I've figured out myself what I'm going to find next.
do you want to find angle CDA first, right?
So you're going to find this angle in here,
Yeah,
correct?
so yes, because then you
Okay.
can find BDC,
Right.
right?
So yeah, you're exactly right. So here we have that guy. And there's an A here, there's a C, whoops, already got C, and they've got the D here. I know this is 30, I know this is 17, and I know this is 28, and I am going to find that angle first. Now, once I find this angle D, won't I then be able to find the guy up here that I'm calling the little dark shaded green guy? So in fact, aren't we going to find this guy first? Now, why am I picking this triangle and not focusing, say, on this triangle or maybe even the big triangle? What is useful about this that none of the other combinations had?
That one
You have-
provides us with an angle.
Yeah.
I have an angle, don't I? And a side matching up. And as long as you've got an angle and a corresponding side, isn't there a good chance that one of the pairs you already know, in which case you should be able to find something out of it? So based on the story that we've got here, won't this be little a, this will be little c, and this guy over here will be little d. And so the lettering is going to have to adjust to take into account. So sine a over little a is sine c over little c is sine d over little d. I know angle A. I know little a. I know little d. Can you see why that means I find this guy? You see why that's the guy I'm going to get. I know angle A and little a. I know little d, so it's pretty natural that I could find angle D. So I'm going to find this guy first. So pay no attention to the order in which you're asked to find things, and don't even expect that you're going to find that right away, because aren't I going to find this angle first? And I'm not even going to get it right away, because I'm going to get this guy before I even find that one. So it's kind of long-winded. So what we have here is sine A over little a and sine D over little d. And that's sine of 30 degrees over 17. And sine D over 28. Cross multiply sine of D 28 times the sine of 30 degrees. Divide both sides by 17. And then to find the angle D, all we need to do is find the inverse sine of this angle. And here goes. The inverse sine of 28 times the sine of 30 divided by 17. And I get the answer. And what did it want? 1 decimal place. So I'm going to get the answer 55.4 degrees. Right. Now, if I tried to find the other angle, we'll just assume that there's only one answer, and that means the first one we find. So I'm making that assumption, and I'm doing that because of the picture, right? If there was 2 answers, I guess it should give me 2 pictures, which means that I now know this angle here is 55.4. So the one that I've got is little dark green shaded, angle C. I'll just call it angle C, but technically it's DCA. Won't that be what's left when you take these 2 away from 180? So 55.4 and 30. And let's see what that gets me. 180, take away the two guys we know. And that's 94.6 degrees. So on this picture, I'm taking that answer back. I jumped to conclusions too quickly. This answer is one of the two possibilities, and I said wrongly, well, there's only one triangle there, so I'm assuming there's one answer. I should have looked more closely. What do you notice about this angle here? Do you notice it's bigger than 90?
It's a hypotenuse, or sorry,
Obtuse,
angle.
right? And so if it's an obtuse angle, is this obtuse? No. So the one that I should have used, it's the other one. Remember, there's two possibilities when you do an inverse sine. There's the one the calculator gives you, and then there's the other one, right? The second quadrant one. So the other one is 180, take away 55.4, and that is 124.6 degrees. Wow. And I didn't notice that until I went over here and I said, 55 degrees? Nah. Would you agree this fella here, 124.6 is more realistic in the picture? So the missing angle is still 180. Take away the two guys that you know. Well, I have a 55.4. No, I don't. I have a 124.6 and I have a 30. So the angle that we're looking for is 180, take away 154.6, and that leaves me with 25.4 degrees. So this guy up here, 25.4 degrees. That was a nice sneaky question. I almost get caught out there. There are two possibilities. And shouldn't you look at the picture to see which one it was? Now, if that one on the right had been a little baby triangle, you know, it was a little skinny one, wouldn't have stuck to the 54 and I'd be happy. But they made that angle a lot fatter. And that was the clue I should have seen to get that one. Well, this picture now is, although it's getting messy, also has a lot of information in it. We are being asked to find this angle up here. And I'm going to do a shortcut. I could find, you know, using the usual, you know, add in things that you know and so on and so forth. I could eventually get the sine rule to do it, but I'm going to do a trick. Do you see that's a straight line? If this is a straight line and that's 124.6, if you take 124.6 degrees away from a straight line, which is 180, you get 55.4 degrees. So that angle is 55.4 degrees. Why is this also 55.4 degrees? I know this is 55.4 because these two make a straight line, which is 180. But why is that one also 55.4? And I'm not using the sine rule to do that.
It's because the two side lengths are both 17.
Yeah, isn't it? It's called an isosceles triangle, the jargon for it, isn't it? But two sides of the same aren't their angles the same. Which means I can now get this guy I've called theta up here, right? The second answer. And this theta up here. Just tell me how I'm going to get the size on.
180 minus the 55.4 plus 55.4.
Right. Does that make sense? 180 take away the two that you know. That's a very common property of straight triangles and of straight lines. As in straight lines are 180 and three sides of a triangle are 180. So I'm going to go in here and do 180 Subtract 55.4, add another 55.4, and the answer I get is 62.9. 69.2, I should say. That was a lot of work in that one, wasn't there? Bear in mind there's some rounding off issues, so the right answer might be 69.3 or 69.1, you know, being that ballpark figure. Kind of like that question now that I almost get caught out in it. Try to draw this picture. This is a version of question 15. And got a triangle that kind of looks like this. Okay, looks something like that. We know this angle in here is 35 degrees. We know the angle up here is 35 degrees. Put a little arrow because I didn't leave myself enough room. I know that a guy called U is 12, so I know this side here is 12. I know a guy called V is also 12. And that's it. And in this question, we're being asked to find the length of AD. So they're asking us to find that distance. In this question, I'm not going to do the whole thing. We are going to talk about the order that you do things. In other words, what you find first, what you find second, and eventually you're going to find AD, but you're not going to get it in one go. Is there anything in that triangle that you know how to find the size of?
The other part of angle C.
Okay. I'm assuming that you are saying that's 35. Agreed? Two sides, two angles. Now, if this is 35 and this is 35, I'll do it in red. What size is that going to be?
$110.
110.
Right. Isn't the trick to rub out bits that don't matter and only focus on the triangle that's of importance at the moment? So are you happy with 180, take away the 235s? Now, I'll change color. So I guess I am doing more than I thought I was going to do. What's the size of the other party D?
70.
Now, if you know that angle and you know that angle, shouldn't you be able to get that angle? Agreed?
Should be 75, right?
Right, 180, take away the thing. I'll put a little arrow because I didn't give myself enough room. Now, in that picture, isn't there now enough information to eventually find the length of AD? Agreed? So once you've kind of done the hunt of writing everything you can find, that ends up being a one sign rule question. But wasn't there a lot of other things to find before you got there? I mean, we did a whole load of stuff like going the scenic route, didn't we? We went all sorts of places just to eventually get to where we could find that. So our next question. I think I'll do two more of these puzzles and then we'll let you figure them out after that. Which one should I do? Let's do 70. So we have a river bank like that, and have a guy over here called A, and a guy over here called B, and a guy down here called C. And we go this way and we go that way. And we're told that this angle is 82 degrees. And we're told that this angle on this side is 52 degrees. And we're told that the distance from here to here is 150 feet. We are being asked to find what? We are being asked to find the distance AC. Is there any information you can find before you start worrying about solving this?
Angle C.
You agree? Angle C. Always think about what do I know before you start worrying about the question. Now, I'll try and this in my head, which is dangerous. It's 134, so you're left with 56, I believe. Great. Now,
I think it's
I get
40.
it's 46.
okay. You all know I can't count, right? So it's 46, so you're on top of me here. Isn't that question pretty much good to go now? Can't you use the sine rule and you could find AC? In fact, won't AC be called little b as far as the sine rule is called, right? The distance AC is called little b. And that's it. I'll leave you to finish that. That one was a lot easier than some, so maybe I could find a really ugly one to finish. Ooh, that looks really ugly. This is a version of question 19. Let me show you the question, because there's a lot of reading in it and I don't want to have to write it down so you know what the question's about. This is my version of question 19. A communication tower, well, by the way, for me, that's the answer. A communication tower is located at the top of a steep hill, right? You can see it here. The angle of inclination is 58 degrees. So that means that horizontal, right, going up the way, 58 degrees. A guy wire is to be attached to the top of the tower. So from there to here is to be attached to the tower of the ground, and to the top of the ground. Let's see, top tower of the ground, and it's 175 meters downhill from the base. So if you measure this guy distance here, it's 175. I better start writing this before I lose track of it all. So we have an angle going like this. We have a vertical going like this. We have a guy going like this. Okay, got that. And we have another line going like that. And we know that this sloping distance is, lost it, it's 175 in red. And the angle alpha is 8 degrees. So that angle there is 8 degrees. And we are being asked to find the height of the tower. Okay, right. Now, everything I just mumbled about there and said, I was writing down it at the time. So let's see if we can figure out from my picture what we know. We know that this tiny little baby angle in here is 8 degrees. And they went and said, let me read that again. A guy wire is attached to the top of the tower. Okay, so I'm glad I checked that. This distance here, right, from there to there is 175. This angle is 8 degrees, and we're being asked to find this height here. And the only other thing that we know is that this angle here, this big one, I guess I'll do it in green. This angle here, right, the whole thing is 58 degrees. And somehow that messy picture is going to allow us to eventually find that. So the first thing I'm going to do is continue this vertical dotted line. And you see there's a little triangle going on here, and there's a big triangle going on here, right? Now, if I draw a very big triangle, which is basically this one here, Would you agree it's right angled? And what do I know about this big angle? This big angle in here is 58 degrees. And don't I know this side here is 175? So far, so good. So what I'm going to do now is I'm going to find this distance. And I'm not going to use the sine rule. Let's call that guy X.
Can't
What?
you just, of the smaller triangle, can't you just find the angle of that? Right?
You want this angle up here? Is that
what do
the
you
one you're
mean?
talking
of
about?
of the small triangle?
Of this one here?
Yeah, can you just find the last angle, right? And then you can do the sine rule for the
Oh,
other length.
I like your thinking. So if I'm picking you up right, and this picture is really messy, isn't that little shaded guy in there 8 degrees? So far, so good, right? Now, if this angle is 58 and this is 90, can't we get this angle in here then? What size is this big angle in here going to be? Right angle triangle adds up to 180. What size is this angle here?
32.
32 degrees. 180, take away the two angles that you know. And that makes this guy 32 degrees. Is that what your thought process was? That's what I think it is, anyway. Is that what you were thinking?
Well, I was thinking find the little angle of the small triangle, right? The last one we don't know of the small triangle, right? And then you can find that big angle on the other
Okay,
side.
well, we've already found that's 32 and we've got that one. So what I'm doing is just a different version of that.
Yeah.
If we know this is 32 and we know this is 8, doesn't that make this guy 140? So it's a different road to the same answer, right?
Yeah.
So the one I was going to do would have worked, but the one I was going to do with SOHCAHTOA first would have been a lot longer. So if I see something quicker, I go for it. So I'm trying to draw that picture, right? And this is the side we're going to try and find. I know the angles are now 32 degrees goes here, 8 degrees go here, and 140 degrees go here. And we know this guy is 175. So if I call this triangle A, I call this triangle B, and I call this triangle C, I think we are good to go. Sine A over little a, sine B over little b, sine angle C over little c. What do I know? I know all the angles. I know little b. And I want to do this guy. And isn't this guy called little a? So the sine of angle A over little a is the sine of angle B over little b. The sine of 8 degrees over, I'm calling it x, is the sine of 140 degrees over 175. And then I'll just leave that guy. Couldn't you find the solution, the missing side x? Now, the way I was going to do it, and now I've changed my mind, is I could have found x. And once I've found x, I would look at this big triangle, which goes like that, and I could have found that side. And then I could have found baby triangle, that side. And then I would have subtracted one from the other. So that was my thought process. And that would have worked too, just a totally different route. I would have been able to do that using only SOHCAHTOA. But this one works, and it's a better one. Good puzzle. You're probably going to have to watch this video and pause it slowly to see all the steps. But I wish I could draw neatly. That would help. So we're now on to our last section for this week. And it's called section 6566. And it's the law of cosines. There are certain combinations of data for triangles that the sine rule, the law of sines, doesn't allow you to find anything. There are two major situations where it falls apart. If I give you a triangle and I tell you all three sides, but nothing else, you cannot use the sine rule. Because won't you check, check, check? And won't you only be able to pick one of the missing angles and there won't be enough information? That situation requires the cosine rule. The second situation, a little bit less obvious, where the sine rule doesn't work, is where you know two sides and the angle between them. And if I gave you that triangle and I asked you to find anything, right, a missing side or an angle, you won't be able to do it. When you do the check marks, the information is all spread out. So can you trust me that if you know three sides, you cannot use the sine rule. And if you know two sides and the angle in between, you cannot use the sine rule to find anything that's missing. And because of that, they had to find a way of solving it. And what they ended up doing is finding what's called the law of cosines. It's basically a formula. And to be really specific, it's two formula. When you know all three sides and you want to find a missing angle, the formula is the cosine of A is B squared plus C squared, take away A squared over 2BC, where little a, little b, and little c. The good news about the law of cosines is that you typically only have one answer, so you don't need to worry about there could be two triangles, right? Now you might say, but that formula is only going to be helpful if I want to find angle A, right? That means that there's really going to be three flavors of this. A different color. What do you think the formula for finding the angle B is?
Would that be a squared plus c squared minus b squared over 2ac?
Correct. And the final flavor is this one. Now, since you noticed it, Aaron, I'm going to keep you off this one, if you don't mind. Look at those two answers and look for patterns, because that's how you're going to memorize this. You only need to really memorize the top one, and you can figure out the other two by patterns. Looking at patterns then, what is the cosine of C going to be?
A squared plus B squared minus C squared divided by 2AB.
Correct. So depending on whether you're being asked to find angle A, angle B, or angle C, won't you have to choose the appropriate formula for the appropriate angle, right? So if I want to find angle C, it's the bottom one. That mess there, by the way, is A, right? Angle B, I'll do the red one. Angle A, I'll do the black one. Now, when you have a situation like this, where you know two sides and the angle in between, there are three flavors to this formula as well. That's a little b, that's a little a, that's a little c. But for this particular combination, you can only do the missing side A, because I already know B and C. So the formula for the missing side A is a squared equals b squared plus c squared, take away 2bc cosine of angle A. It's basically a rearrangement of this formula. Again, it's all to do with parts. Suppose I wanted to find little b, right? So I knew what A and C was, and I was trying to find little b. So I would use a formula that would be b squared equals. I need to know what that guy's going to be. Any suggestions?
B squared is equal to a squared plus c squared minus 2ac cosine b.
Great. And occasionally, isn't it, you're going to have to find little c, right? And in little c, what would the formula be now?
A squared plus B squared minus AB times cosine of C.
Almost right, just two of them. Right? So what I'm going to do next is just write down a triangle with some information and talk about what's going to happen next after that. So this is going to be A, this is going to be C, that guy's there. So there's going to be little A, it's going to be little C, there's little B, right? There's a standard triangle. And I'm going to tell you that this is 10 and this is 12, and that's 32 degrees. So there are really two questions I'm about to ask. The first question is, what do you find, or what can you find using one of the cosine rules in this story? And then tell me the formula that would be.
You can
So-
find the length c.
Yeah. Isn't that the only thing you can find in this story, is little c? Two sides and the angle in between gets you sides. Now, since it's little c, I'll start it for you. What formula would we use?
A squared plus B squared minus 2AB cosine C.
Correct. Now let's take that to the next stage. Let's show you how this formula works then. It's 12 squared plus 10 squared. Take away 2 times 10 times 12 times the cosine of 32 degrees. Now the good news is that although that's really ugly, do you know you can do it in one go on your calculator? So let's see if we can see it. So it's 12 squared, add 10 squared, subtract 2 times 10 times 12 times the cosine of 32. And the answer, at least the number we're going to use, is that guy. But don't you have to do one extra step to find C? So that missing length isn't 40.47, right? It's too big. That would never fit. What will I do to find missing C?
Square root it.
And since it's a length, I only need to worry about the positive guy. So I can do the square root. I can actually just get the calculator to type it all by saying square root of answer. And that ends up being 6.4 to 1 decimal place. Are you comfortable with that? Here's a couple of things that make life really easy. If I tell you two sides and the angle in between, there is only one answer and it's always possible. You know, like in the sine, sometimes there's two answers, sometimes there's one, sometimes there's none, right? You've got that issue, not this time. If I give you two sides and the angle in between, there is one answer and you'll be able to get it, right? Now I'm putting, for this kind of the last question of the day, I'm going to put a monkey wrench in the question. It's going to be called PQR. And this side is 5, this side is 8, and this side is 5 and 8. And this side 17. What can you find in a triangle where that's the information?
You can find any of the angles.
Right. Does it really, one of them is no more or less important than the other two, agreed? Would you agree up here, there's no choice. It must be the third side. You don't, there's nothing else. But in this, it could be P, it could be Q, it could be R, right? So here's my problem for you. I want to find P.
So can you just choose one of the angles, right? And then
Yeah,
after
unless, yeah.
and then after you get that angle, can't you then use the law of sine?
Yep.
Okay.
Exactly. Or they might just ask you for one angle, in which case you're finished. But what you said is right. Have you noticed I've changed the lettering? It's not ABC, it's PQR. So now you have to figure out what the formula is using little p, little q, and little r. That's the monkey in the wrench part. Now I've decided, for no particular reason, I want to find that angle, right? So that means I'm going to start with the cosine of P. Now, you have to tell me what the formula is based on just what I've given you. So it's something like this, right? But it doesn't use A, B's, and C's.
Q squared plus R squared minus P squared divided by 2 QR.
Nailed it. How did you figure that out, Ali? Can you kind of put it in English?
I mean, PQR is like its own order in the alphabet, so I kind of just replaced it with A, B, and C.
Yeah, so you just said P was A and Q was B, and yeah, that's a good way to do it. If the letters are a bit like separated, R, T, and V or something, then you could do that technique as well. Now let's continue this and see what we get.
If you found it too confusing, you could always just switch them to A, B, C, and then switch them back when you had your final answer, right?
Yeah, that would work. Yeah, if it really freaks you out, couldn't you just say you're A now, you're B, and you're C when you get the answer, right? If it really freaks you out. Now, Q squared is 8 squared, then it's 5 squared, then it's going to be take away 17 squared, and then it's going to be 2 times 8 times 5. Now, you can do this horrible calculation in one go, but there's one thing you need to do. You need to put brackets around things. If you don't, you get the wrong answer. So here we go, bracket, 8 squared. Add 5 squared. Take away 17 squared. Close the bracket. Divided by, put a bracket around it, 2 times 8 times 5, close the bracket. Now, do you notice I did everything in the top inside a big bracket and everything in the bottom? So when you hit the answer, don't be surprised by a negative number. Well, be surprised by that negative number. Oh, shooting space. I made an impossible triangle. There, I'll make that 18. I can fix it. So, pretend it was always 18. Same calculation. That was just me making an impossible question. Insert 18. Yeah, that's much better. And there's the answer. And it ends up being 0.75. What would I do to find P if the cosine of P is 0.75?
Inverse cosine.
Inverse cosine. And inverse cosine, I'll just say of the answer. Yes.
Did you put 18 on the bottom instead of 8 when you replaced it?
I put 18 here. Oh, darn it in space. I didn't, did I, young lady? Well caught.
Thanks.
I'm getting old. Third time lucky. 18 squared plus 5 squared, take away 17 squared, close the bracket. Divided by, to a bracket, 2 times, it should have been 18 in the bottom as well, times 5. And I get that number, which is fine. It's a different number, but it's the right number. So I'm now going to do the inverse cosine of that guy. So inverse cosine of the answer. And the answer I get is 70.5
So
degrees.
since it's 0.333, you could just put in the inverse cosine of 1/3 to be more accurate, right?
Yeah, although when I went and hit the ands, the calculator was doing that
Yeah.
for me. Yeah. Okay, let me show you that calculation without brackets to show you why brackets are important. If I went 18 squared, add 5 squared, and take away 17 squared, and then I said divided by, and then I just did the 2 times the 18 times the 5. Would you agree negative 12,000 is probably not right? Right. So the chances are something stupid like that will appear if you forget your brackets, right? And it's a good idea to worry about that. Yes.
Because this is like the inverse of cosine, does that mean there can be 2 answers, like the inverse of sine, or no?
Ah, good question. You're going to like the answer. No. The other possible cosine angle is 300 and something, which will never work.
Okay.
Because in the cosine, the other angle's in the 4th quadrant.
Oh, okay.
So,
Thank you. Yeah.
so when you're doing missing sides or missing angles and you're using the cosine rule to find them, the good news is there's one answer. So whatever one you've got is the only one you need to worry about, which kind of makes life a lot easier, right? When you're using the sine rule, however, and all bets off, you have to be careful because there might be 2 answers. Oh, good question. Are we good? Last name, say bye-bye.
Bye.
Bye-bye.
Thank you.
And I will see you tomorrow. And we will continue with the cosine rule because that's the last thing we need for this week.
Thank you. Bye.
Bye.